So this lesson on estimating solutions has you working with rounding numbers, and there's kind of two ways to estimate solutions to equations. The first way is to solve the equation like you normally would and then just round your answer, so your rounding step is last. The other method for estimating solutions is to round everything first up to the nearest integer, and then your answer is an approximate answer. So we'll look at both different methods. So the first one has you rounding your answer to the nearest tenth place. And when determining how to answer questions like this, mainly you're looking for something that says rounding your answer, and that will indicate to you that you should solve it like you normally would, but then round as your last step. So in this equation, 4.2x minus 5.4 equals 16.4. If we want to round our answer, we're just going to solve this equation like we have been, so using inverse operations. So right now, 4.2x, and then subtracting 5.4 from that, this is where we want to start. The opposite of subtracting 5.4 is to add 5.4, and we are going to add 5.4 to both sides. So minus 5.4 plus 5.4 is 0, leaving us with 4.2x. And then if we add 16.4 plus 5.4, we end up with it's 21.8. So now 4.2 times something equals 21.8. We're going to divide both sides by 4.2. And 21.8 divided by 4.2, I get a long decimal. So the decimal I got was 5.19047, and it keeps going. We want to round to the nearest tenth place. So here's our tenth place. When we look one digit after, it's a 9. So we're going to round the 1 up to a 2. So we would say that x is approximately equal to 5.2. So when you're rounding your answer still might be a decimal. When you're rounding and you estimate with the coefficients first, you may end up with a nice number that's not a decimal. But this squiggly equal sign just means that x is approximately equal to 5.2. It doesn't exactly equal 5.2, but it's really close. So the other method for estimating solutions is if you round your integers first. So this would mean you round all of the integers with the coefficients and the constants up to the nearest whole integer and then solve. So remember the rules for rounding. If it's 5 or greater, you round up. If it's anything below 5, you're going to round down. So in this case, 4.2, that's a 2, so I'm going to round it down so that it's just 4x minus 5.4, still below 5, so minus 5. And then 6.4, still below 5, so I'm going to round to 16. And now you can solve knowing that, and this actually should be a squiggly equal sign. It's approximate now because we've already done our rounding. So now we would add 5 on both sides to get 4x is approximately equal to 21. And then if we take 21 and divide by 4, we get x is approximately equal to 5.25. So this is where we would round first and then get our answer. And rounding it this way may come out to be a nice number. It might not. The last concept is determining if an estimate is a reasonable answer. Is it reasonable to expect that as an answer? So in this example, Sal is going to the grocery store with a total of $20. And he's buying bread for $2.05, milk for $1.99, candy for 99 cents, chicken for $6.25, and cat food for $4.99. And then he knows that the sales tax is 5%, and Sal is expecting to get about $3 and change. So they want to know, is this $3 and change, is that a reasonable estimate for how much money he should get back? And so what I would recommend doing for this one is round all of your item values to whole numbers. So our $2.05 in milk, I would say that that's $2. And then our $1.99, our $2.05 for bread, and then our $1.99 for milk, I would round that up to $2. 99 cents for candy, that's really close to $1, so I would say that that's $1. Chicken for $6.25. Since this is less than half of $1, I would round down to $6, so plus $6. And then cat food for $4.99, that's really close to $5. So right now, if we add up how much this is, 2 and 2 is 4, plus 1 more is 5, 5 and 10, plus 6 is 16. So right now, without tax, he's spending about $16. If we want to estimate how much the tax is going to be, if we multiply 16 times 0.05, this comes out to be about 80 cents. So 80 cents, that's close to $1. So if we think $1 in tax, that comes out to be $17 that he's expecting to spend. So then think about your question now. Is it reasonable to expect him to have $3 back in change? If he's starting with 20 and we subtract the 17, that $3 is a reasonable answer. So I would say yes, that estimate of $3 is reasonable.